Okay, young people, so there was a time where when you bought an item at a store, they didn't just scan it across there and it would go bleep, bleep, bleep. There was actually a cash register that a person had to type the price in, okay, manually. So what we're talking about is before we had scanners, the overcharge rate was about 1%. So about 1% of the time it was estimated the customer got overcharged back in the day when we had to type the price in to a cash register manually, okay? So basically what we're saying is the percentage of the time that we overcharge people was equal to 1%. This was before we had checkout scanners, okay? So that's the percentage of the time. The question basically is, now that we have scanners, bleep, 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 has that overcharge rate changed significantly? Changed. Is it different than the 1% that it used to be? How about we say, therefore, not equal? It's not the same as it used to be. All right? Now, we would hope that, so changed. Has it changed? Not equal to what it used to be. We'd like to think that it's gotten better. It's more accurate. We're not overcharging customers as much as we used to, but you never know. So, there would be our setup here. The overcharge rate before we had scanners, and we're checking to see if it's different, if it's changed, now that we have scanners. So, here's our test statistic again. We're going to use a 5% level of significance, and again, I'll provide that for you. But in general, in life, you could pick whatever you wanted for that. There's a whole science behind how to pick that, and all that kind of stuff. But here's the deal. Because of the not equals, we talked about this on our first example, you would hopefully agree, and I'll take you back to it if you need the reminder, but if you have a not equal to, it's going to be a two-tailed test. And we'll interpret what these tails represent here in a moment, but if you take half of that 5%, that's 2.5%, 0.025. I should be drawing these bigger, but I don't have a lot of board space, so I'm really sorry. But if you put half of that on both sides, 2.5 in the lower tail, 2.5 in the upper tail, you're only going to give 5% to that alternative, and you're going to give all the rest to the null. All right, and again, we need to find those z-scores. And here we go again, our beautiful table. Our table, we go, hey table. But this table, there's others that give you tails. This isn't it. This table always wants that middle sliver. Same discussion as many times before. The upper half of the bell curve, which is 0.5, minus that tail would be 0.475. 475 and 025 add up to 0.5. Same thing over here. So we're talking about middle slivers of 4750. Hey table, I got a picture for you. I got a couple middle slivers, 4750. Really? Is it going to... Table time. All right. 4750, 1.96. Negative 1.96, positive 1.96. There's two possible rejection regions. It's a two-tailed test. Okay, now, I think once we write this down, I can take a shot at explaining what each of these tails represent. Let's describe this one. If we're out here beyond negative, so how would that be written? If z is less than negative 1.96, I think that would describe that lower tail. That's one possibility. Or if it's z greater than 1.96. We are about to collect some data to see what percentage of people get overcharged using scanners and put it in here and see what happens. Now, let's talk about it. If that z-score lands out here, doesn't that mean that now that we have scanners, we're overcharging customers less than we used to. Yes, and to me, that would mean better. Customers are being overcharged less than they used to be overcharged. If we land up here, wouldn't that upper tail tell us that the overcharge rate, that customers are being overcharged more than they used to be when we had manual cash registers? That's the idea. Either way, changed. It's either changed for the better, we're overcharging people less than we used to, or it's gotten worse. We're overcharging people more than we used to. That opens up both possibilities. Okay, so 1,234 items were checked, and 20 of them were overcharged. 20 out of 1,234, which by the way, I think that's a crazy decimal. Just for perspective, 20 divided by 1,234 is, you know what that is? That's about 0.016, blah, blah, blah. Now I'd point out, just looking at that, that's higher than 1%, isn't it? And if I was going to predict, I would say, you know what? That's going to be above. It's going to be above 1%. If we're going to get a rejection, it looks like it's going to happen up here. Okay? But that's the question is, how much higher than 1% is this? So, now that's a nasty decimal. So again, the p hat would need to be plugged in as 20 over 1,234 minus the p, the overcharge rate of 1%, back when we had manual cash registers, and then p is 1%, and q would be 99, right? 1%, 99%, p and q, and then n is the 1,234. So again, I invite you to push buttons, hit pause, try not to peek at the next slide. Let's see if you can crunch this out yourself. It doesn't do you any good to look it up and just cheat, right? So I hope, here, you do that while I'm going to set the stage for this. All right, there's some great links coming up here maybe. I don't know. You'll be the judge. But I hope you got a z-score there of 2.192. And yes, there's a lot that happened between here and here. But that's order of operations. That's college algebra, okay? We're towards the end of the semester in stats. So the number crunching's got to be a formality by now. But that 2.192, I would point out to you, would indeed be out there beyond the 1.96. Okay? So wouldn't that be enough evidence to reject that null hypothesis? Reject the null hypothesis. All right, let's see if it works this time.
Plus their guard play is so
I don't know what happened to my
they
video
go
here.
9 people deep and not lose anything. You know?
No, and the other, yeah, the other
This
guys
is
are
a
like
Sonic commercial.
starting maybe 6 man.
Right.
Maybe
Yeah,
6
that.
man.
Darn it.
Rejected! Don't you bring that weak tot action. You go strong to your mouth and you don't go at all.
I don't know what happened to my video. All right, anyway, maybe when I updated my computer, that format doesn't work anymore. Anyway, we reject the null hypothesis. I was going to tell you a very cute story about a former student named Megan Margaret McCrary and rejection and all that. She knows what I'm talking about. Maybe I'll share this with her. But since the video didn't work, it kind of takes it away. I'm sorry, Megan. I was really excited about sharing that story. I'm going to see if I can fix that so that when we do this again, it'll work. But anyway, we reject the null hypothesis. Now, if you reject the null hypothesis, you gave it the majority of the bell curve, and yet the data took you beyond the p-hat, the sample, you would reject it. And doesn't that support the proposition that the overcharge rate has indeed changed significantly, hasn't it? So, and not only that, how did it change? Well, aren't we overcharging customers more than we used to? So actually, honestly, the problem's gotten worse. Now I'll tell you that I made up the data here, so don't go thinking that, you know, that these stores are ripping you off on purpose, but anyway, that's the idea there. So it really would be important to check those receipts, wouldn't it? Make sure you check your receipts. Let's hope that this one works. Speaking of receipts. Now, let's see. Let me do this. Sorry.
I bought a donut and they gave me a receipt for the donut. I don't need a receipt for a donut. I'll just give you the money, you give me the donut. End of transaction. We don't need to bring ink and paper into this. I just can't imagine a scenario where I'd have to prove that I bought a donut. Some skeptical friend, don't even act like I didn't get that donut. I got the documentation right here. Oh wait, it's back home in the file. Under D. The donut.
The donut receipt. All right. Anyway, to me that's classic. So I think that covers hypothesis testing. I'm trying to think if there's anything else that needs to be mentioned here. I don't believe so. I wish you the very best on assignment 24. Look at these examples, look at the notes, look at the answers. Good luck, everybody.